All right, class. How are you all doing? All right, I want us to look at Newton's laws of motion. Then we shall look at some calculations involving these laws. We shall look at the first, second, and the third laws of motion. The laws of motion talks about how force is related to a body accelerating. It talks about how force is related to a body that changes direction or a body in motion, and how force is causes a body at rest to move from one point to another. Okay, just a quick one. The first law of motion, which is called the law of inertia. The law says that a body will continue to remain at rest or in a uniform motion unless acted upon by an external force. Okay, that means when a body is kept in position at rest, the body will remain at rest until a force is applied to change the position of that body to another position. Okay. So if no force is applied, that means the body will continue to remain at that particular position. Alright. So let's look at the first law. I've already stated the first law. If I have a body, let's say on a rough surface, and the body is kept here on the surface. Alright. So this body, according to the first law of motion, that this body will remain at rest, will remain in this position unless a force is applied. When the force is applied on this body, the body will accelerate, the body will change its position from one point to another. Okay, but because this is a rough surface, for this body to change position, the applied force must be greater than the frictional force. The applied force must be greater than the frictional force. In this case, the frictional force here is static. You know, we have two types of friction. We have the static friction, we have the kinetic friction. The static friction is a kind of friction that keeps a body or that keeps a body at rest. Any object at rest is being held by a static friction on a rough surface. Alright? So if the applied force is greater than the frictional force, let's say we have a frictional force F but don't forget that the frictional force we are considering is the static frictional force. Okay, so if the applied force is greater than the body will accelerate right along the horizontal direction. So that means the sum of all the forces acting along the horizontal axis is simply the applied force minus the frictional force, which is equals to mass times acceleration along the horizontal axis. Alright. Okay, why do we say Fa minus? If this is the direction of motion, we have two forces that act on this body. We have the applied force and we have the frictional force. The applied force is simply in the direction of motion. The object is moving this way. The applied force is acting in the direction of motion, or the applied force is acting in the direction of acceleration of the body, right? While the frictional force is acting against it. So because the applied force is acting in the direction of motion, it becomes positive Fa. The frictional force is acting against acceleration, that means it becomes minus Fr. The sum of all these forces, which is called the resultant force, is equal to mass times acceleration along the horizontal axis. Now what if we have a surface which is a smooth surface, a surface that is not rough, and the body is kept here. Alright? The body is kept on a smooth surface. That means the only force that can be applied here for this body to move from one point to another is just the applied force. On a smooth surface, we are saying that frictional force is negligible, right? Okay, so the only force that can only act on this body, for this body to change position, is the applied force. So sum of all the forces acting on this body is simply equals to the applied force, right? The applied force, which is equals to mass times acceleration along the horizontal axis. Okay, so when you have a body, this is the case of a rough surface, this is a case of a smooth surface. This is for rough surface, this is for smooth surface. What if we have a case whereby a body is kept on a rough surface, the body is kept on a rough surface, and we are asked to find the force that is needed to keep this body at rest. Find the force required to keep the body at rest. The body is already at rest. The force needed to keep this body at rest is our sum of Fx equals to 0, meaning we don't need any force to keep the body at rest because the body is already at rest. I see many jam questions, many university questions, many questions, many objective questions in some universities and some exam body. And question comes like this: when the body is kept at rest, what is the force required to keep the body at rest? Or they will tell you a body of mass 2 kilograms on at rest is at rest on a rough surface or on a smooth surface. What is the force needed to keep the body at rest? As long as the body is already at rest, the body is not moving. The force needed to keep the body at rest is zero. There is none. There's none. So take note of these conditions. When we have a rough surface, a body kept on a rough surface, and the force is applied on this rough surface, right? Then we have a smooth surface, a force is applied on a smooth surface because the surface is smooth. There's no frictional force acting on this body. So the only force that acts on this body is the applied force. So for a body kept at rest, the only force needed to keep the body at rest is equals to zero. Now let's see another case of a body. Now if I have another case here, if I have another case here, let's say I have a body kept on a rough surface, and this body is being dragged with a rope. The rope has a tension. It's being dragged with a rope at an angle called theta. Alright? It's being dragged with a rope at an angle called theta. And we have to find the acceleration of the body. I believe that from this we can find our acceleration by making our AS as the study of the formula, right? Okay. And we have to find the acceleration of the body. Now what do we do here is that because this tensional force is along this horizontal axis, this force can be resolved into two components. Don't forget that we have a force here, right, that acts on the body, which is our normal reaction, same as N. We have another force here, which is the weight of the body, which is same as what? Mg. For the other diagrams, we also have R equals to N and W equals to what? Mg. For this, my weight is W equals to what? Mg. Here, my normal reaction is R equals to N equals to Mg. For this also, R is equals to Mg. Then the weight here, W equals to what? Mg. But in this case here, the value of my normal reaction is not equals to Mg because this body is being dragged with a rope making an angle theta. That means we have a force here which is supporting the normal reaction. For other diagrams, we don't have any force supporting the normal reaction. So normal reaction equals the weight of the body. Even for the rough surface, the first diagram we drew. So let me show us again the first diagram. Here we have normal, the weight is acting downward. Here we have normal what? Reaction, which is also equal to mg. Then we have the applied force, which is our Fa. Because the surface is rough, there must be a frictional force, which is what? Fr. So for this, the sum of all the forces we have already discussed is equals to Fa minus Fr, all equals to what? Max. So to find my acceleration, I can easily find acceleration of the body along the horizontal axis. So the sum of forces acting vertically is zero because the body is not accelerating vertically. Even from this diagram, the sum of all forces along the vertical axis is zero. So the body is moving horizontally. Is that not? Okay. But for this diagram here, where we have an angle theta, then we have our tension here. Then this tension can be resolved into two forces, Ty and what? And Tx. Now because I have a force here, when you pull a body with a rope, although the body is moving along the horizontal axis, but this force here, Ty, is supporting the normal reaction. So this normal reaction can no longer be equal to what? Mg because I have a tensional force that is supporting it. Alright? And this tensional force is acting in the same direction as the normal reaction. The Ty is acting in the same direction. So the sum of all forces acting vertically upward is simply R, right? Plus what? Plus Ty. And this sum of all forces should be equal to what? Sum of all downward forces. R plus Ty equals to what? Mg. Right? From here I can make my R as subject of the formula. My normal reaction then becomes what? Yeah? Mg minus what? Minus Ty. Normal reaction is equal to Mg minus T1. Alright? Okay, so that's my normal reaction. But I want us to look at the horizontal forces acting on this body. Let's consider the horizontal force acting on this body. So for this, the since I have a rough surface, that means my frictional force must be acting in this direction. So the sum of all the forces along the x-axis is, if this is my direction of motion, if motion is this way, that means if the body is accelerating towards this direction. Okay, so that means that the sum of all forces will be equals to Tx minus Fr. Ts minus Fr. Alright? Why do we say Ts? Because Ts is acting in the direction of motion. It's moving towards the direction of motion where the body is accelerating towards, right? While Fr is moving against it. But I want us to understand that in vector resolution, whenever the angle theta is along the x-axis, okay, I'm to resolve this tensional force in two components, Ts and Ty. Ts simply means the horizontal force, horizontal component force. Ty means the vertical component force. Ts can be resolved as T cos theta, okay? While Ty can be resolved as T sin theta. Please don't forget, whenever the angle of inclination is along the horizontal axis, Ts becomes T cos theta, Ty becomes T sin theta. But we all know, and I want to believe that if I have a force here, if I have an angle here, this angle is now along the vertical component. If I'm to resolve my Ts, it becomes T sin theta, Ty becomes T cos theta, meaning the reverse of this. But because the angle we are considering is the angle along the horizontal axis, so the resolution of Ts will be T cos theta, while that of Ty will be T sin theta. So from here, I can say that my sum of all forces along the x-axis become my Ts is T cos theta minus Fr, all equals to max. All equals to max. But don't forget that your frictional force here can either be static frictional force or kinetic frictional force. When we come to friction, I'm going to explain this aspect of motion of the body. We'll look at different cases when the body is accelerating along the horizontal axis, when the body is accelerating along an inclined plane like this, when the body is accelerating using an inclined plane. Alright? I will explain. I'm going to show us how to find acceleration of the body with several cases and all that. Okay? So these are just some of the applications of Newton's first law of motion I want us to consider. After now, we'll be solving some problems regarding this aspect of Newton's first law of motion. Okay, now let's look at the first example. Alright? Okay, I want us to look at this equation we have here. Alright, this is the general equation. The equation is a moving car of mass 800 kilograms. Here we are given that the mass of the car is 800 kilograms. Experiences a frictional force. Frictional force is 2,200 Newton. 200 Newton. If it accelerates at 2 meters per second squared, calculate the size of the force applied. Okay, we have a moving car. Since we are told that the moving car has a mass of 800 kilograms, experiences a frictional force. That means the surface is the rough surface, right? The frictional force there is given as 200 Newton. Alright? And we are told that the body accelerates at 2 meters per second. Acceleration is 2 meters per second squared, rather. The body accelerates at 2 meters per second squared. So the body moves. Okay. So calculate the size of the force applied. The size of the force applied. We are looking for the applied force. But don't forget that sum of all forces along the x-axis is simply the applied force, right? Minus the frictional force. All equals to mass times acceleration along the horizontal axis. So for me to find the applied force, I have to move the frictional force to the other side, becomes positive, right? So that means my applied force is simply our mass times acceleration plus frictional force. Okay, already we are told that the mass of the body is given as 800 kilograms. So here we have 800 times, so acceleration is given as 2 meters per second times 2 plus the frictional force is 200 Newton. So the applied force becomes 800 times 2 is 1,600 plus 200. So the applied force becomes 1,800 Newton. This is the applied force of the body. Let's see the second question, alright? Okay, next question. Example 2 says a block of 20 kilograms is pulled with a force of 10 Newton at an angle of 30 degrees with the horizontal. Find the acceleration of the block. Alright, so we have a block here. Solution. We have a block here. A block. The mass of the block is given as 20 kilograms. Alright. This block is pulled with a force of 10 Newton. Alright. The force. Our tensional force. Or tension. Or let me say force of 10 Newton. Right. Alright. At an angle of 30 degrees. You know, we say that if I have a force here, I have a force, okay, applied on a body at a certain angle, that this force can be resolved in two components, right? We can resolve this force. We have Fx and we have Fy, right? Why am I using F? Because we are told that the block is pulled with a force. If this force is interchange with tension, I would have used the word T here. But since there's a force of 10 Newton at an angle of 30 degrees, alright, with the horizontal, find the acceleration of the block. So that means that to find the acceleration, the block here is only accelerating along the x-axis, right? So we say that the sum of all the forces acting along the x-axis is simply the Fx, right? The horizontal force, which is equal to what here? NAX. Okay, we look at we have to find the acceleration of the block, right? Look at this question. This question, there's no reference to frictional force. We're not told that this block is kept on the rough surface, right? So the only reference given to us is that there's a force of 10 Newton acting on the block at a certain angle 30 degrees. So I'm going to neglect friction. So that means the sum of all forces acting on this body is simply the horizontal force rather, which is our Fs. If this body is kept on a rough surface, that means I'll be considering the frictional force, right? Which is my Fr. This will not be minus what? Fr. But because there is no reference to friction in this question, I'm going to neglect the frictional force. Or I can say frictional force is equal to 0, right? Okay, but the sum of all of these forces along the x-axis is also equal to mass times what? Acceleration. Don't forget that this Fs here can be resolved as F cos theta, while Fy is resolved as F sine theta. Okay, so that means the sum of all forces, which is equal to our Fs is F cos theta, all equals to mass times acceleration along the horizontal axis. But we have to find the acceleration of the block. So I will make my As as instead of the formula, so my As becomes As equals to F cos theta divided by mass. So my Ax then becomes, our force is given as 10 times cos 30 divided by the mass of the body is given as 20. Okay, so 0 can cancel 0 here. Cos 30 is simply 0.8660. So my acceleration is 1 times 0.8660 divided by 2. So my acceleration becomes divided by 2. Acceleration becomes 0.433 meter per second square. This is the acceleration of the block. Let's see another question again, alright? Okay, the third question here says a force of 300 Newton is applied across a 20 kilogram box. Okay, the frictional force acting on the box is 200 Newton. What is the net horizontal force on the box? Calculate the acceleration of the box. How far will the box travel after 12 seconds if it continues to accelerate at this rate starting from rest? The force applied is given as 300 Newton. The frictional force is given as 200 Newton, right? Okay, we have to find the net horizontal force on the box, calculate the acceleration of the box, how far will the bus travel after 12 seconds if it continues to accelerate at this rate, starting from rest. Okay, so since we are told to find the net horizontal force, so that means this body is kept along the horizontal axis but on a rough surface. So we are told that the applied force is given as 300 Newton. The resisting force, the force that tends to resist the motion, is given as 200. The mass of the body, the mass is given as 20 kilograms. Right, so we have to find the net horizontal force. So the first question, sum of all forces is simply the applied force minus frictional force. So that will give us applied force is 300 minus the frictional force is 200. Right, so sum of all the forces is equals to 100 Newton. Alright, now the paper says calculate the acceleration of the box. Number 2, recall that to find the acceleration of the box, after recall that sum of all horizontal force is equals to mass times acceleration, right? Because sum of all of these forces must be equals to what? MAS. So it means that my AX equals sum of all forces over what? Mass. Sum of all forces we got is 100 Newton. The mass of the body is actually 20 Newton. Alright, so 0 can go 0, 2 years 1, 2 years will give us 5 meter per second square. So my acceleration is 5 meter per second square. Then the third one says we should calculate how far will the bus travel after 12 seconds if it continues to accelerate in this same rate starting from rest. When the body starts from rest, it means that the initial speed, right, or initial velocity is equal to 0. So how far simply means find the distance. And from the equation of motion, distance is given as ut plus half at squared. Yeah, we know that since the body is starting from rest, so our u, initial speed, is 0 meter per second. So here becomes our distance is equal to 0 times t plus half times acceleration is given as 5 here, times our t is given as 12. We tell after 12 seconds. So our t, the time there is 12 seconds, which is 12 squared. And this will give us distance equals 0 plus half times 5 times 12 squared is 144. By the time we multiply out, 144 multiply with 5, then divide by 2. That will give us 360. So our distance is 360 meters. Please take note of this. 360 meters. Now let's look at the Newton's second law of motion. This law is also called the law of acceleration, right? And the law says that the rate of change of momentum of a body is proportional to the applied force, which takes place in the direction of that force. Alright? The rate of change of momentum. But what the law is saying is that the force is proportional to the rate of change of momentum, which is what mg minus u divided by what? By t. We call this rate of change of momentum proportional to what? To the applied force. This is actually direct proportionality. Okay, that shows that as the rate of change is increasing, the force will also increase. Alright? So that means force is negative, it's positive to the rate of change of momentum of a body. Okay. Now, if we are to take off this sign of proportionality, I have to introduce two things, equal sign and a constant. And that will give us F equals K M V minus U divided by what? By T. Alright, so for this force to be defined, I have to make K equals to what? 1 or equals to unity. For the force to be properly defined, the value of K must be equals to 1. So if K is equal to 1, that means my force is equals to mass times changing velocity divided by what? By time. Alright. And I want us to recall or remember that, let's call this equation 1. Remember or recall that acceleration of the body is same as change in momentum divided by 1 by t. So if my acceleration represents v minus u over t, so this entire expression becomes force equals to mass times acceleration. Alright. Now there are some certain terminologies that are associated with Newton's second law of motion, which are: the first is force, number 2 is impulse, number 3 is momentum. Momentum. We know force as an agent that causes a change in position of the body, right? Also causes a change in direction of the body, also causes a change in shape of the body, or an agent that causes a motion. Alright, and force can be classified into two. We have the contact force and the force field. Right, contact force simply means when there's a contact between two objects. The first experience there is contact force. Then we have force field, is the kind of force that happens around the region of an object. Right, for example, we have magnetic force field, magnetic force, electric force, gravitational force. Then under contact force, we have frictional force is a good example of contact force, right? So I've defined force. And force is a vector quantity measured in Newton. Alright, so the next one is called impulse. Impulse simply means change in momentum of the body, or it's a product of force and time. The product of force and time. From this equation 1 we have here, by the time we cross multiply this equation, if we are saying that force is equals to mass times change in velocity over time, by the time we cross multiply this, this will give us what? Ft equals to mv minus u. Okay, but don't forget that we say that impulse is the product of force times time. So impulse is also defined as change in momentum of the body. When there's a change in momentum of the body, it's also defined as impulse. So impulse is product of force times time or change in momentum of the body. Impulse is measured in Newton seconds. It's measured in Newton what? Second. Alright. Then the next thing is momentum. Momentum is defined as the product of mass and its velocity. Product of mass of a body and its velocity. Okay, that's momentum. And the symbol is this. So momentum is mass times velocity. Mass is measured in kilogram. Velocity is measured in meter per second. So momentum is given as kilogram meter per second, right? Okay, so these are the various terms we can associate with Newton's second law of motion. Now let's solve some problems regarding this law of motion. Alright, we have a question that says that an 8 kilogram object speed up from 20 meter per second to 50 meter per second in 6 seconds. Our initial speed is 20 meter per second. Our final speed is 50 meter per second. And we also find, okay, the time is in 6 seconds. We also find what is the acceleration of the body. Okay, the first question says acceleration of the body. Okay, acceleration of the body we have already defined from the second law of motion that is given as v minus u divided by t, right? Change in velocity divided by t. That will give us our acceleration. So my addition becomes, so the value of a, which is my acceleration, becomes our v is 50 minus our u is 20 divided by 6. Alright, so my value of a becomes 50 minus 20 is 30. 30 over what? 6. This will give us 5 meter per second squared for acceleration. Then number 2 says, what is the net horizontal force acting on the body? Number 2, the net force acting on the body is Fx, which is equals to mass times acceleration of the body. So this acceleration is actually the horizontal acceleration, right? Which is my NAX. So in this case, we also find the net force. which will give us our mass of the body is 8. Okay, 8 times 5. The net force here is 40 Newton. 8 times 5 is 40. Alright, so the next, number 3, is that if the frictional force is 35 Newton, what is the applied force on the body? That means in this case now, we are not going to draw a diagram to illustrate this, or we can just continue. Okay, just recall that sum of all forces is equals to the applied force minus the frictional force. So if frictional force is 35, what is the applied force? So applied force, all of this is equals to what? MAX. Okay, I can also say that applied force is equals to MAX plus frictional force, which is same as FA equals MAX is same as sum of all forces, right? Sum of all forces Fx plus frictional force. So the applied force is going to be sum of all forces. Okay, we got the answer as 40 plus frictional force we are giving is 35. 35. Okay, 35. So by the time we add up this, the sum of all forces, 40 plus 35 will give us 75 Newton. Okay, let's see the next question. Okay, let's look at this question here that says that a body of mass 20 kilograms is set in motion by two forces, 3 Newton and 4 Newton, acting at right angle to each other. Determine the magnitude of the force, direction of the resultant force, and the magnitude of its acceleration. Okay, we're not told that the forces are placed maybe along the x-axis or the y-axis. We are told that a body of mass 20 kilograms is set in motion by two forces. These two forces are acting at right angle to each other. So I'm going to assume that the two forces are placed in the first quadrant, right? In the first quadrant. If I have my quadrant here, the first, second, third, and fourth, I'm going to place the two forces here. We have the first force and we have the second force. We are told that they are both placed at the right angle to each other. So let's take this force to be 4 Newton and this force to be 3 Newton. Alright, okay. Then the direction of the force should be this way. We have this and we have this. Then this should be our angle of theta, right? Okay. This question seems faulty because we are not told that the 4 Newton force is acting towards the east, then the 3 Newton force is acting towards the north. We're not told where they are acting, so we're not supposed to present the equation in this format. We're not meant to find the direction of the resultant force because the direction of the 4 Newton and the 3 Newton force is not given. So I think the second question is faulty. But except I'm going to assume that the 4 Newton force is acting towards the east, while the 3 Newton force is acting towards the north, because we are told that these two forces forms a right angle triangle to each other, right? Okay, so we are looking at the case where they are both in the first quadrant. Now what we do is we are also find the magnitude of the force which is this. Let's call here our F, our force. Okay, now to find the force here, we're going to use a theorem called Pythagoras theorem that says that, let me call here point A, point B, and point C. So using Pythagoras theorem, because we have the right angle triangle, the only theorem we can adopt for a right angle triangle is the Pythagoras theorem. So that says that the square of the hypotenuse, which is AB squared, equals the square of the adjacent, which is AC squared, or the square of the opposite, which is BC squared. So our AB is the force, right? F squared equals our AC is 4 squared plus 3 squared. So my F squared becomes 16 plus 9, right? By the time we add up these two forces, we're going to have 25. So the next is to find the magnitude of the force. So it means I will square root both sides. By the time we square root both sides, force will then be square root of what? 25. The force applied will then be 5 Newton. So the size of the force is 5 Newton. Alright, then the next one is the direction. Like I said, this is 40, but I'm assuming that the 4 Newton force is acting towards the east, while the 3 Newton force is acting towards the north. So direction is theta, right? Okay. So for direction, since this force is assumed to be placed in the first quadrant, you can use any of the trig. You can either use sine theta, cos theta, or tan theta. So let's use tan theta to find the direction using tan theta. The word tan is from the word toa, right? Toa, and toa means opposite over what? Adjacent. Opposite is 3, 4 is the adjacent. So we're going to have 3 over 4. By the time we punch our calculator, let's see what we have there. When you divide 3 by 4, that will give us tan theta equals 0.75. So to find the angle, you can tan inverse of 0.75. Okay, tan inverse is 36.86. So our theta here is 36.87 degree. 36.87. This represents the direction of the resultant force. Now the next one says find the acceleration of the force. The third one says acceleration. Recall that force is equal to what? Mass times acceleration. So my acceleration becomes the force divided by what? By the mass. So our force we got is 5 Newton, right? 5 divided by the mass of the body is 20. Is that not? So my acceleration should be 5 here 1, 5 here 4, which is 1 over 4 meter per second squared. Alright, so this is the equation, the answers to this very question. Alright, I want us to look at this question. This question is under the third law of motion. Third law of motion says that to every action there is always an equal and opposite reaction. That means action and reaction are equal but opposites, right? Okay, this law is called the law of action and reaction. Now we have a question that says that a 120 kilogram skater pushes against a 80 kilogram skater. After contact, the 80 kilogram skater was given an acceleration of 1.5 meter per second squared. What is the acceleration of the 120 kilogram skater? Now, yeah, this is a good example of the third law of motion. Okay, so what we're going to do here is that we're going to say that let F1 represent force of the 120 kilogram skater. Then let F2 represent force of the 80 kilogram skater. Okay, since we are told that action and reaction are equal but opposite, the action was done by 120. The reaction was experienced by 80 kilogram skater, because this 80 kilogram skater was given an acceleration of 1.5 meter per second squared. So I'm going to say that my F1 is equal to minus F2. Action and reaction, they are equal but opposite. Equal means F1 is equal to F2, but they have to move in different direction, which is this negative sign. Are you there, somebody? Okay, and remember that we say that force is equal to what? MA, right? So if force is equal to MA, so here the force on F1 then be what? M1 A1 equals to minus M2 A2. Okay, our job is to find the acceleration of the 120 kilogram skater, right? That means we are looking for our A1, because F1 represents 120, F2 represents 80 kilogram. So M1 is the mass of the first skater, which is 120, right? A1 is the acceleration of the 120 skater. M2 represents 80 kilogram skater. Our A2 is given as 1.5 meter per second squared, right? Because the 80 kilogram skater was given an acceleration of 1.5 meter per second squared. Now let's move on. So we have here to be our M1 is given as, let me itemize our figure so we can solve. Let me itemize them. Our M1 is 120 kilogram Here, my M2 is 80 kilogram, right? My A1 is unknown. My A2, our A2 is giving us 1.5 meter per second squared. 1.5 meter per second squared. By the time we solve, that will give us what? 120 times A1 equals to 80 times 1.5. So we're going to have 120 A1 equals 80 times 1.5 is 120. Okay, but don't forget that here we are having minus sign here because the two forces are equal but what opposite. So negative sign must be maintained on this other side, right? So to find my acceleration, it means my A1 becomes minus 120 divided by what? 120. So our A1 becomes minus 1.0 meter per second squared. This is to tell you that the 120 kilogram skater experiences a retardation, okay, a reaction, a backward acceleration, a retardation, a backward reaction. When the 120 kilogram skater pushes against this 80 kilogram skater, okay, we are told that the 80 kilogram skater moves in the direction of 1.5. This is a forward acceleration because it's positive. So the negative sign for the 120 shows that there was a retardation, there was a backward, there was a reaction at the end of the action, right? Which is a negative acceleration. Okay. Now, the next question says, what force was exerted on each skater? What force was exerted on each skater? For F1, we know that F1 is M1 A1. That will give us our M1 is 120, right? 120 times our A1 is minus 1.0. So the force here F1 is minus 120 Newton. Okay. For F2 is going to be M2 A2. And that will give us F2 equals our M2 is 1.5 times. So our M2 is 80 rather. 80 times 1.5. By the time we multiply these two, that will give us 120 Newton. Now we can see that the two forces are actually equal but opposite in direction. The two forces are equal but opposite. So action and reaction are equal but opposite. This is the Newton's third law of motion. Alright guys, I'm going to stop here for now on this Newton's laws of motion. In my next class, I will emphasize on collision, okay, as regards to the Newton's third law and second law of motion. I will talk about the types of collision, which are elastic, inelastic, and completely inelastic collision. I also discuss about coefficient of restitution, how two or more bodies collide elastically and inelastically, and how they collide and how they stick together after collision. So much to discuss under Newton's laws of motion. So do me a favor, please ensure you subscribe to this YouTube channel and ensure you share the link to your other classmates. And if you have any challenge, any topic you want us to teach, you can drop that topic in the comment section. Thank you.